I don't dare touch that. The stainless came out pretty good. I seem to have gotten it all the way around. That would probably hold. Don here in Florida, and today I'm going to ask a question. Can you weld with water? The answer is no. If I rephrase that, can I weld with water? The answer is yes. And how do we do that? Well, and I'm not selling this, by the way. We do it with a Multiplaz 3500. I know if you go on some of the welding sites, on some of the forums and stuff, you'll see a lot of basically uneducated people that don't quite understand this, and you'll see all kinds of comments and basically opinions, because you have to know fact before you go dispelling information to people. And fact number one is, yes, this welder does use water to weld. Actually, it doesn't use water to weld. It uses plasma to weld. What it uses the water for is to create a very high pressure dry steam within a chamber inside of here. And I'm going to take this apart in a few minutes and you'll see this. And that high pressure dry steam actually drives the plasma forward through the tip here. This end is basically just like any type of plasma cutter. It's got an anode and a cathode. It creates an arc in here utilizing voltage, and you change. When you create that plasma, you need a way to force it through. In a normal plasma cutter, you would use air normally, and that air just basically blows the plasma and you can cut with it. Well, here we don't use air. We don't have to have an air compressor or anything like that. We simply just open up the chamber, use an injector, inject water into it, and that's it. Close it up, fire it up, and that steam pressure is up almost immediately. You know, if it's been setting for a few days, I'll let it run for 3 or 4 minutes before I'll start using it, just to basically blow out any residual water and stuff or condensation that might have been in there. But otherwise than that, if you're stopping and starting with this all the time, you can basically just push that button on the back and keep on going. It's nothing to it. Normally in a plasma cutter we have a very small tip end, and this is to make it very directional. But they found that to weld with plasma, if you used a larger tip end, you could control that plasma much better and actually weld with it, and that's what we'll do. Some of the inaccuracies that you'll find when you start reading about these, I almost believe that Miller and Lincoln probably have trolls out there trying to discredit this. But one of the things that you'll read out there is that you can't weld with water, you have to have gas, you have to have argon, you have to have helium, so on and so forth. They're semi-correct there. I find it interesting that nobody's actually addressed this issue, because if you've been a guy that's welded with argon and helium and believe that you always have to have those gases, they're forgetting one thing, and that's CO2. And one of the things that they're not saying about the Multiplaz is that when you mix up your water here, and I'll throw that out, you basically take some clean water, and this is out of my dehumidifier, so this is nice and clean, and you mix it with basically rubbing alcohol. This is 91% rubbing alcohol. I've seen all kinds of different mixture rates out there. The book gives you different mixture rates, but I don't sweat it too much. I basically just mix it 50-50. This is 91% rubbing alcohol and 100% H2O, so that comes out to what, 60-40, somewhere around there. It's not that imperative. So you mix up your water and your alcohol, and this is where people go off track. When you mix the water and alcohol, what you're basically doing is you're giving this thing a fuel to create gas. When you create that plasma arc, and you're using that steam pressure to push that plasma arc out, if this alcohol is along for the ride, this alcohol burns and becomes carbon dioxide, which is the third gas that nobody really talks about. And this is really important because that carbon dioxide, aside from creating that same gas layer or displacement of oxygen that argon or helium would do, does it better with the high temperatures that this creates, because the regular welder, your MIG welder, your TIG welder, is only welding in the 4,000 to 5,000 degree range. This is welding upwards of around 14,000 degrees. So that carbon dioxide really creates a better gas barrier than like helium or argon would do. Now I always worried about that, and when I bought this tool, I noticed right away that it welded very good. I mean, this is an incredibly good welding tool. Working with it, and one of the kids in my welding class asked me, "Hey, how come there's no rust form after you use that? It's just like a MIG weld," and it got me to thinking. So a later class I was also teaching a green technologies class, and we decided to find out what was up with this. So what we did was we took a gas meter and we put it in an 8-inch tube, and the tube was about 18 inches long. We put it about 3/4 of the way down that tube, and then we fired this up and brought it down to the end of the tube to blow whatever gas was coming out of there through. And the first thing I noticed on that meter was that the CO2 level just skyrocketed. It peaked. It blew out any other gases that were readable. So it told me almost immediately that it was CO2 that was coming, and it dawned on me then that it was the alcohol that was creating that. Run it with just water, because the cutting torch runs with just water. The cutting torch doesn't have that level of CO2. Yeah, it has some CO2, but not that level. So obviously it was the alcohol doing that. And with this, you basically don't even change anything. I mean, you might even have a slightly higher reading of oxygen with the cutting torch, and that's basically because of the breakdown of the water. But with the welding torch and the alcohol in there, it's definitely a lot of CO2 coming out. So that was obviously my gas barrier that I needed for good welding. And so that's one of the things they don't talk about. So yeah, the water, the guys that down these don't understand really what the water is doing. The lack of argon or helium, again, they don't understand what's going on. And those are really the two big things that need to be brought out about this tool, because other than that, this has become my go-to tool. The other thing is that I found was the economy of this tool. When I started teaching in the welding and metal fab department there at the school, we had TIG welders. My first year out there, what I found was, the kids always break up the MIG welders. You're not going to get around that. They break up MIG welders like crazy, and you're always fixing them. But the TIG welders, they were going through consumables so fast that basically by the second year in there, I had to wipe that TIG welder off the board. They were burning up all our budget with the materials on TIG, and even to this day, I'd like to have a TIG welder in here just for aluminum. And I can get by with this because I think a TIG welder does excel on aluminum. And the aluminum welding that you would do with this is basically capillary action welding. Because it does weld at such a high temperature, you can weld a lot of different types of materials together. One of my favorite stories was I was doing an after-school STEM club, and we wanted to build go-karts in that club. And we had mild steel frames for the go-karts, but we didn't have any mild steel pans to put in them. All we had was some stainless steel from some thrown away kitchen equipment. And so we pulled out those stainless steel pans, cut them up, and I thought I was just gonna tack weld it in with this and then use a bunch of screws to hold the pans in. But this thing just 1-inch tacks end to end on those pans, and I'll tell you what, that's all it needed. And I think that's the thing, when you heat the metal to that temperature, whatever structure is in the metal causes it to meld together and become one maybe different or dissimilar or disliking metal, but they do bond together. Another area that this really excels at is cast iron. I had some broken tabs on a Opal exhaust manifold, and we were looking for a new manifold, and I just thought, I wonder if I could weld those. And I did. I took some normal steel rod, ground some grooves into the tabs a little bit so that I'd have some space to weld. Welded the tabs right in, let it go. It was perfect. You couldn't even tell it was a weld. It looked like the original casting by the time I got done. You know, I got stories out the yazoo about the different things that this is welded together and welded well. Different types of materials, different thicknesses, you know, different grades. It doesn't care. It's going to weld it. Another area that it welds good is stainless steel. I have no issue welding stainless steel with this. You know, once you've gone through that learning curve of how to use one of these, you really can't beat them. It does become your go-to, especially if you're in a maintenance shop. If you're in a fabrication shop, no. You're probably going to want a MIG welder where you've got wire just feeding out all day long. But for maintenance people, this is just an amazing tool. Or if you're just... All right, so I'm going to go ahead and get set up. We're going to tear this apart and clean it. And after we get done cleaning it, we're going to go over the welding table, give you a couple demos, and see what you think, okay? Give me a minute. And this is the welding head, and I use the welding head probably 100 to 1 to the cutting head. I use this all the time. So let's get this apart. Start with the end here. And see, that pops right off of there, no problem. There is a little screwdriver on here to get into this cap. Take that cap out, just pops out like that. And then this barrel just turns right out. If you have, and then of course we can take the cathode off here. And, you know, we could leave it on for cleanup. Actually, most of the time I do, but let's just do complete tear down on this. And we'll just loosen this retainer. We don't need to actually take that out. As a matter of fact, I'd hate to try to reseat it back in there. So, and if need be, if you've already taken the cathode out, you can reach in and just pull it out like that. So, and that one's actually pretty clean here. What we really find getting dirty are the tubes on the inside here, so we want to get that tube out. So this is the supplied dowel for that. It's nylon, and that's used just to push it out. And you can see how dirty that gets. You can see that end's just all corroded up with copper, and that's from the burning process creating the plasma. Okay, so that was pretty easy. That's basically the teardown right there, unless you want to take this out, which you don't have to do. That's it. That's all the parts inside of this thing, and this is going to be a real easy cleanup. To do it, I'm just going to get a cup like this. I have this water out of my dehumidifier, which I know is clean, so we'll use this. A little bit of simple green. That's about all I use. Simple green or some Ram. I like that Ram a lot, and we'll just get some of that on there to get it started. Put it down in the water, and I guess I could put this stuff to start soaking as well. Makes for easier cleanup. I don't need to soak that. And I'll start with a little baby brush here just to get the worst of it out, and then move up from there if need be. So, and you can use Scotch-Brite. I like to take Scotch-Brite and cut off little slivers of it and run that through. I don't have any Scotch-Brite at the house today, so I'm going to take a little piece of steel wool here, and this works just as well. And I'll take the steel wool, and it has to be fine steel wool. Don't use that coarse stuff. And we'll run that in there, and take a wooden dowel. I like to use a wooden dowel because it doesn't score anything. And see, it's got quite a good amount of buildup right there. So we'll run that in to the end so that I can get onto it, and then I'll just twist it through like this, and that starts taking it out pretty good. So we'll let that soak a little bit more, and we'll start cleaning this up. This is actually in pretty darn good shape. When I took the cutting head apart, that was just nasty. I'd been using it for probably more than 6 months off and on and never cleaned it, and it was just filthy in there. So this one here is nothing compared to what the cutting hand was. So see, that cleans off pretty nice. And we'll shine that up, and we'll run some of this through there. So just get the worst of it going here. And then this here, you see down here, there's a little bit, and up here. And the rest of it seems to be in pretty good shape. Yeah, see, that just a little bit of soaking really helped that. So we're going to soak it some more. And while that's soaking, I'm going to go over on the Scotch-Brite there and finish cleaning that up. Just polish it a little bit. Yeah, see, and that's just about all you need to do right there. I'll run some steel wool through the middle here just to make sure there's nothing pounded up in there. So, and we'll run it from this end, simply because there's some fingers in there. They're one-way fingers. They lock the glass tube in there, so we've got to go this direction. So I'll always start from the end down. There we go. Like I said, this end is what takes most of the brunt of the nastiness, so we'll get this end cleaned up as good as we can. And like I said, this is looking pretty good. I'll go give that one last polish up. All right, and there's that. That's all cleaned up. And what to do with that end? There she is, right there. So let's go ahead and clean that up a little bit. Actually, to do this, I'm just going to screw it right back on there. That's not very dirty. And I'm going to put that right over on the Scotch-Brite as well. There, that's nice with the Scotch-Brite. It cleans and contours it nicely. And I'm going to put some more graphite grease on those threads because they've been in there for a while. And the tube, let's see how the tube's coming. There, that tube looks nice. So let's dry it off. And I'm just going to check for cracks. And like I said, I can't see too good, so I'm just going to run my finger around like that. Now right there, I feel a little indentation in the glass, which is probably not a good thing. So I think this is going to go on my far end. Let's check this end here. Doesn't feel like a crack. These tubes are very sensitive. If it doesn't fire, it's usually the tube. And last but least, this part here, this is very easy. Usually just take a little piece of emery cloth and run it in there. Just give it a few twists. If you can see the copper in there, you're good. So when it starts getting so black that you can't see copper, then you just give it a little clean out, and that's about it. There's not much to it. As far as the outer portion goes, when I'm welding over there, I'll show you. Basically just take a brass brush and run it over the end to make sure it's clean as we're welding. And if it clumps anything up that welds it to the tip here, I have a file available. I'll just file that in. It looks like there is a little bit of slag right there that needs to be filed up, but I'll do that with it on here. So it's just a lot easier. And that's just a holder. That really doesn't matter. So that's about it. That's about as clean as that needs to be. And just like the other one, we can start reassembly. We'll take the spring, slide it up on here. And again, the graphite grease, very, very, very conservative amount. Don't get crazy on that. I put just a dab on the end of my finger, and that's more than enough for everything here. So it goes a long, long way. Okay, so we're going to go ahead and get our tube in again. Which end did I say had slight indentation in the glass? Right there. It's not chipped. It's not cracked. It's like a little bit of glass is missing right there. Probably not enough to affect it. So it's the cracks that are really the problem. So we'll get that up in there like that, flush. Get our spring on there. Get that down in there. I put the graphite grease on there, so I'm twisting it in. And then again, this goes up. See the flat up here, right there? That flat faces up towards that retainer. So get that all the way down in there. And we'll give it a twist back and forth to make sure we're kind of centered on that, and then lock it. I'm going to just kind of move that back and forth as I'm doing that to make sure it's staying in there and flat. There we go. And then I'll finish tightening up the cathode here. And I've already got the graphite on here, so this goes in like that. And honestly, I'm kind of going slow doing this because it's a show and tell. This is actually a lot faster than what I'm doing it. I found that this is far and away easier to keep up than say your TIG, and if you're having issues with a MIG, forget it. So, and that's it. She's all set up. So make sure she runs freely. And she does. Okay, what I have here is my dedicated cart. I actually use this welder more than any of my other welding equipment, so I did dedicate a cart to it just to hold all the stuff, welding rods and equipment and tools and that sort of thing, and grinders, clamps, all this sort of thing. So one thing I always keep up here is this cup. You want to have cooling water available, because yes, you do cool this when you're done using it. And I also keep some nozzle gel, because I do like to put some nozzle gel to it when I'm done. Keeps everything kind of working nicely. And that's about it. So we're going to go ahead and get going here. I went ahead and prepped the surfaces a little bit here. We're just going to weld these plates together and then fill this hole a little bit. There's a gentleman, Yoti, from South Africa. He's got a lot of really good welding stuff with the Multiplaz 3500. I would definitely check him out. I am here in Florida at the end of August, and it's like 2,000 degrees outside and 4,000% humidity, so this isn't a fun task, so we're going to keep this to a minimum. But I would definitely take a look at Yoti's stuff. Where I would disagree with Yoti though is in surface prep. He said you can just go ahead and weld through anything. I disagree with him simply because you are putting impurities into the weld, which can weaken the weld. The cleaner that weld is, the better that weld's going to be. So just kind of always keep that in mind. It doesn't matter if you're welding with a stick welder or a Multiplaz. Always have clean surfaces, okay? So let's go ahead and see what we can do here just for... Okay, so we got the machine on, and we're going to go ahead and get charged up here. So to charge it up, this is the water alcohol mix. I'm going to mix that up inside the can a little bit here because I just poured that in. There we go. And we're going to charge this till we get a little bit of water coming out the end there. There we go. That charged real quick. And all we really need is a pair of these number 5 glasses. I use these for welding. They work just fine. And I'm going to wear some lightweight gloves. We're just going to give a couple of quick demos on this. Alright, so to get it started up, I hope that's in the frame. You can go ahead and turn it to on, and it's going to be on whatever its last setting was. There we go. And she is blowing out a little water because we just cleaned this. So I'm going to let her run here for a minute while I get ready. The ground line I'm just going to hook straight onto the table, just like you would with arc welding. This is a grounded handle. This is to keep you safe from any current that might be flowing and gone astray. It's always good to have those safety procedures in place, right? All right, now we're going to leave it on number 4. And in this position right here, in mode 1, we have 2 modes. Mode 1, which is just a regular flame here. We would normally braze with that and solder. It would do the equivalent of gas welding. We're going to go to mode 2 though, and we're going to raise it up a little bit here because we want to actually weld with plasma. So we're set up for that now, and we'll see how it goes. Well, not my best effort, but it welded. And then for filling, it's basically the same deal. But the nice thing about this is you can really control the rod when you're filling with this. Something about plasma just is so much more controllable than an arc welder. Arc welders, I think, are too aggressive. And I'm gonna go ahead and get these pieces of, let me put that up there. I'm gonna get this stainless steel pipe and we're gonna weld that together. Okay, so that wasn't my best weld, but that will definitely hold. It's 100% penetration. The filling came in pretty good. I got a little bit slow there at the end. The nice thing about the plasma is that if you're welding and you do blow a hole in something, you can fill that hole on the fly. You don't have to let it cool and come back to it and work at it. So it's really nice that way. All right, I'm not going to bother giving a demo on the plasma cutting because the cutting's just like the welding, and if you've seen a plasma cutter in action anywhere else, it's exactly the same. Okay, it's just loading this like I did and plasma cutting like you would with any other plasma cutter. So it's way too hot even for me to be out here at this point, so we're going to skip that part. If you watch my Monarch 10EE videos, the first ones I did, I showed the back panel and I brazed through that, and this will braze like you wouldn't believe. I brazed through that like I was, you know, pushing solder through a piece of tin. It was nothing. So it's really an amazing tool for a multitude of issues. All right, just some last thoughts here. The Multiplaz 3500 was actually developed by the Russians for the International Space Station, and I can see why. It gives off no poisonous gas. The carbon dioxide that it does emit can be scrubbed in space, so there's no issue there. They don't have to carry big cans of argon and helium. Welding in space seems kind of far-fetched, but who the heck knows what goes on up there, right? But that's originally what it was developed for. I really knew nothing about them until I picked up my favorite issue of Farm Show magazine. If anybody doesn't read this Farm Show newspaper, you ought to read it. It's really good. But I read about it in here before I bought it. And honestly, like I said, this has become my go-to welder. It does all the weird, odd jobs that you probably couldn't do with any other normal type of welder. It does it for a lot cheaper. I know the price of them has come up a little bit since I bought mine, but inflation, I mean, it's here. I'm sorry, nothing we can do about that. Like I said, for some really interesting welding, watch Yodi. He really does some good stuff with the Multiplaz 3500. There's another. Anyway, I guess that just about covers it. So like I always say, down here in Florida, sweating with the oldies. In Florida, Don out.